Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be talking about how to find x and y intercepts for rational functions. So in case you forget what a rational function is, or maybe no one ever taught you, in which case I blame your teacher. A rational function is simply any function that has x in both the numerator and the denominator, and it looks something like this. It can also be a factored form, like for instance, this is also a rational function. And the question is, how can we find the x and y intercepts of these functions? So in another video, I talk about how to find horizontal and vertical asymptotes. That, of course, is important too. But this is just going to be about finding x and y intercepts, which in case you forget, an x and y intercept is where the graph crosses the x and y axis. And these rational functions usually look something like this, where they have both a vertical and a horizontal asymptote. But today we're talking about the x-intercepts, which is where it crosses the x-axis, and the y-intercepts, which is where it crosses the y-axis. And I'm going to be showing you how to find both of these today. So first, for x-intercepts, the goal is you're going to set the y equal to 0, and you're going to solve for x. Keep in mind, you can have more than one x-intercept. You can also have 0 x-intercepts. That's possible as well. And the other thing we have to know for x-intercepts is that we have to check for holes in the graph, and I'm going to be explaining how to do that. Well, might as well just explain it now. If, for instance, I have x minus 2 times x plus 1 over x plus 3 times x minus 2, the x minus 2 would cancel because it shows up in the numerator and the denominator, making it a hole at x equals positive 2. It would not be a vertical asymptote. It would not be an x-intercept. It is only called a hole, and that happens whenever it cancels in the numerator and the denominator. And we have to check for that with the x-intercepts. It's not going to happen for the y-intercept, but it can happen for the x-intercept. And so that's everything I have to say for x-intercepts. Again, y equals 0, solve for x. Don't forget that. And by the way, this holds true for the x-intercept for literally any function, not just rational ones, but rational ones are extra fun. So that's why I have a video on just rational functions. And now for the y-intercept, you guessed it, we're going to be setting x equal to 0 and solve for y. And as far as the y-intercepts go, you can either have 0 or you can have 1. You cannot have anything else. And so with that, let's do some example problems and start to get better at this. So for the questions we're going to do today, it's just find the x and y intercepts, and that's it. So here's the first one. Let's find the x-intercepts first. Remember, that's where I set y equal to 0 and solve for x. So it looks like this. Now here's the thing. If you want to solve for x, you'd have to multiply the denominator on both sides, because that's going to make the denominator go away. So in other words, I'm saying 0 times x squared minus x minus 6 equals just x minus 2 on the right. And what you'll notice happen, and why this is so great, is because this entire left side, anything times 0 is 0. So it's just 0 equals x minus 2. Great. And so it looks like the denominator is not going to matter for this problem, or really any problem when it comes to the x-intercept. In other words, if you just want to set the numerator equal to 0, that's fine. That's good. And you will get an answer of x equals 2. And before I circle this as the final answer, I do have to check for holes. How do I check for holes? Well, I have to try and see if I can factor the numerator and denominator and see if anything cancels. So if I want to factor the denominator, the factors of 6, there's two pairs, 1 and 6, or 3 and 2, needs to subtract to negative x right there. So that would be x minus 3 times x plus 2. That's my denominator. The numerator is x minus 2, which means, does anything cancel? We get pretty close, but nope, we are safe. If this was x minus 2, then it would cancel. It would be a hole in the graph, and the answer would be no x-intercepts. But because it did not cancel, as you can see, then that means x equals 2 is my answer, or sometimes they want you to write it like this, 2 comma 0. Why 2 comma 0? Well, because remember, it's x comma y, and literally the first thing we did was we said y equals 0. So that's why it's 0. And it will always be 0 for the x-intercept. And when we soon do the y-intercept, I'll tell you the y-intercept is always 0 in the x position, and you're basically solving for y. In other words, it's flip-flopped for the y-intercept, which makes sense. So final answer, 2, 0 for the x-intercept. Now for the y-intercept for this problem. This is where I'm setting x equal to 0, and we're solving for y. So the y-intercept is almost always easier to find. Very simple. Y equals negative 2 over negative 6. This will be y equals 1/3, or how I like to write it, 0 comma 1/3 for the y-intercept. And again, I'm not checking for holes for the y-intercept because it's very rare when it happens, and it would only happen if an x canceled, like a lone x, not anything else next to it. And since that doesn't happen here, then 0 comma 1/3 is good for our answer. So that's it for this one. Now let's do another one. Y equals x squared minus 4 over x. If you want to give this one a try on your own, go ahead. If not, here's the answer. So first I'll find the x-intercepts. Again, that's when y equals 0, and it looks like this. But really, I only care about setting the numerator equal to 0. So that means 0 equals x squared minus 4. I can add 4 to both sides, or you can factor it, but this way is easier. And then I just have to take the square root. When I take the square root, do not forget this. All my students forget it. You need to do plus or minus, and so therefore the answer is x equals plus or minus 2. And how I'd like to write this is like this. 2 comma 0 and negative 2 comma 0. This is the best way to write it. So that's it for the x-intercepts. I should check for holes in the graph. I already know there's not going to be any. Because if I do try and factor the x squared minus 4, you'll get x plus 2 and x minus 2 over x. Nothing cancels, so no holes, meaning I keep both answers. And then for the y-intercept, we need to set x equal to 0. And so in other words, this ends up being negative 4 divided by 0. And this is interesting because divided by 0, we know that's undefined. But what am I going to write for my answer? Well, the answer is none. There is no y-intercepts because you can't have a 0 in the denominator. And that's it. We're done. Case closed. And now we're going to do one more. Again, I encourage you to try this one on your own, especially now. So get out some paper and give it a try. Give it the old college try, or if you're in high school, the old high school try. Or if you're in middle school, then I'm surprised you're watching this video. So I'll give you a second to do that. And when you're ready to see the solution, unpause it. Okay, here we go. So first, for the x-intercept, I have to set y equal to 0. Honestly, I can just worry about the numerator right now. And if I want to solve this, I need to factor it. Factors of 15, you got 1 and 15, and 3 and 5. I think 3 and 5 are going to be best because 5 minus 3 is the positive 2 in the middle. So in other words, 0 equals x plus 5 times x minus 3. So that means x equals negative 5 and positive 3. But again, I do have to check just if there's any holes. And so if I want to check for holes, then I basically have to factor the numerator and the denominator. We already did the numerator, x plus 5 times x minus 3. And if you factor the denominator correctly, well, you have 1 and 10 and 2 and 5. Since it's plus, it means they have the same sign, either both positive or both negative. And since it's a minus 7 in the middle, I have a feeling it's going to be negative 2 and negative 5 like this. So since there's no holes in the graph, we get to keep both answers, negative 5 and positive 3. Although I should write it like this, negative 5 comma 0 and 3 comma 0. And that's our answer. And now we'll find the y-intercept. Again, that's when x is equal to 0, which honestly you'll probably like a lot more because there's no factoring involved. And so in other words, we're just going to get negative 15 in the numerator and 10 in the denominator. That reduces to negative 3/2, which is my answer. And then usually I like to write it like 0, -3/2. And there we go. That's how we find x and y intercepts for rational functions in algebra. Thank you all for watching this video. I hope you have a great rest of your day, and I'll be sure to see you in the next one. Take care, and bye-bye.